Good afternoon. My name is Jenna-Lee Keefe-Singer, and I'm with the Special Competitive Studies Project. Our next speaker is Chris Taylor. He's CEO of Alaria, a tech company revolutionizing communications and connectivity. Prior to his leadership with Alaria, he served as CEO of Govini and CEO of Mission Essential, and he founded Novitas. Thank you for joining us today, Chris. Please welcome to the stage.
Well, good afternoon. It's been a wonderful day of candor and insight, and it's really great seeing so many people that I haven't seen for such a long time. So I'm glad to see you all. Ash Carter was my advisor and a professor of mine in grad school. And as we all know, Ash was brilliant. He was direct. And when he was right, he knew that he was right, and he was telling you that he was right. Tragically, I have the same DNA. So during our advisor sessions, we would have some passionate discussions. And during one of these discussions, we were going back and forth, and it wasn't getting hot, it was getting warm, if you will, back and forth, back and forth, back and forth, back and forth, until finally Ash said to me, "Chris, is it your intent to overthrow the government of the United States of America?" I said, no, I'm a Marine. Of course that's not my goal. He said, "Well, you just do what I'm telling you to do." I said, "Sure." What were we arguing about? The classes that I was going to take that semester. God's honest truth, we went at it for a little bit. He didn't want me to take 2 classes. There's much more to this story. I'll save it for the reception. It was a very good discussion. But that's not really the sole reason that I'm here today. Our company, Alaria, is actually a live manifestation of Ash's creation of the Defense Innovation Unit. About 15 months ago, I and some investors acquired 2 technologies from Google. One is a temporospatial software-defined networking architecture, which I'm going to demonstrate for you today. And the other is a coherent light free space optics program that wasn't really announced in Google. Just after we closed the deal about 15 months ago, DIU released a commercial solutions RFP for hybrid space architecture, and we applied. We went through the process, and ultimately we were awarded an OTA to be the network foundation of the DoD's hybrid space architecture. None of that happens if Ash had not started DIU. None of it happens if Mike Madsen, if Mike's still here, if Mike had not listened to everything that I kept trying to tell him why this was a good thing for the department. It doesn't happen. So we have a really direct line between Ash's contributions to the department and hopefully our success. As we go through the demonstration today, I hope you'll keep in mind some of the things that Bob Work and General Smith were talking about, and many others. And that is, if we're trying to connect everything to everything else, because everyone has seen PowerPoints with those little lightning bolts on them that represent some sort of connectivity that we simply don't have. What I think I'm going to show you today is that it does exist, and it is available today. And I think after you see it, you're going to say to yourself, we should probably 10-tuple DIU's budget, staff them to the bejesus, and just set them free. At least that's what I hope you're going to think after this. So with your permission, I'm going to just show you a little bit around our platform. Now, I just want to remind everybody that I'm the CEO, not the CTO. My CTOs are watching right now. We have co-CTOs, Brian Barrett and Nathan Wolf. More importantly, my 5-year-old daughter, I think, is watching right now. So periodically, if you clap and say yay, it helps me a lot at home tonight at dinner. I appreciate that. Okay, so what you're looking at right here is the space, what we call space-time, temporal spatial software-defined networking platform. It's in my browser, which I'm using Chrome, and I'm just going to walk you through some of the things that we have. What are we actually looking at? So we're looking at about 9 satellites in geostationary orbit. We're looking at about 27 satellites in MEO, and we're looking at a bunch of satellites in LEO that basically try sort of to replicate SDA's architecture, or satellite architecture going forward. So that's what you're looking at. You'll also notice that we have a series of ground stations that are going across the United States and down with our friends in Australia. The white lines you see, the bright white lines you see, are active inter-satellite links. The less bright white lines are inter-satellite links, but the system's simply not using them right now. One of the other thing that you should know is that space-time right now thinks it's actually flying this system. So this isn't a demonstration, it's an emulation. Each one of these satellites, or 40% of the satellites, have a COM package on it to replicate V-band. And we only made 40% so that we could force the system to think that there were constraints. And I'll talk a little bit about the constraints that we're able to use to help mission in just a second. Another one of the features that we're looking at is we ingest real-time weather 24/7. So about 140,000 weather stations are being ingested right now. We also ingest stuff from, weather from the European Climate Weather Program. Additionally, we also are, just for the sake of convincing you that the system has no a priori knowledge of ships and planes in it, we're ingesting live AIS and ADSB aviation and maritime information. So what you see is live. Real planes, real weather, real ships. Okay, so what does this mean? I have no idea why that's happening. Okay. So one of the things that you can also see here is that we're able to predict weather. So what you see here is actual precipitation being ingested into the system. Wind speed, that's also, and we do use wind speed. We use cloud moisture. Not cloud cover, cloud moisture. And then, of course, we use surface temperature as well. Why? Because all of these weather phenomena have direct effect on both RF and optical links around the world. And this will be important as we go through this. One of the other things is that you'll see here that we have a long connection to what? We have a long connection to the moon. And what did we do? We went to the moon and we actually placed COM packages at all the Apollo landing sites. We then had those Apollo landing site COM packages point to a Lagrange 1 satellite so that it could then connect with everything that we have on Earth. So we've tried to cover all of what we're seeing. So let me go to a region of interest. How about INDOPACOM? So as we look through here, we can actually see that there are a number of gateways and planes sharing connectivity from a satellite. So a satellite to a plane that's sharing connectivity with itself already. And the same thing with ships and planes. So this flight right here, which is live, is a United Airlines flight that's crossing right now, right? And another ship up here. Sorry, the system, not my system, the internet connection is a little slow. Is a ship that's also moving. So the ability for us to connect everything to everything else says that we can connect the moon to a Lagrange 1 point, to satellites in GEO, MEO, and LEO, to ships, to planes, to ground stations, and to anything else that we want to connect them to. How is that possible? Google invested a pretty good amount of money in helping to be able to create a digital twin that allows us to match the wireless transceivers in a digital twin on a planetary scale. So we can connect any two set of transceivers that are compatible everywhere around the world. Why does that matter? For those of you who are familiar with what goes on in the Department of Defense and other places, we buy lots of things that were never meant to talk to other things. We buy lots of things that were meant to talk to other things, but then we bought newer things that aren't able to talk to those things. And we go on and on and on and on. The way we've designed this is so that we can make use of everything, every new discovery that the department wants to add to its JADC2 environment or its hybrid space architecture environment is able to be connected instantaneously. And that's the thing that is probably one of the biggest things about this. The theme today has been resilient communications and what have you. So let me just show you something quickly. So if I pick a satellite here, and this is live, this one has 5 links and 12 forwarded routes. Let's assume for a second that we're in some sort of, on some sort of mission, and we're gonna take this satellite out. Or I'll take one out that anybody else wants me to. You can pick any one, but let's start with this one. So if I take this out, now I can kill its inner satellite links, its gateway links, anything. But if I take the whole satellite, I'm gonna disable the whole thing, what you should see is that the system is right now reconfiguring and remessaging before I got done with the demonstration, that satellite and the system just reconfigured the entire network of the affected nodes, imposing a strategic dilemma on our adversaries because what they thought was going to happen when they took a satellite out did not happen. It was reconfigured in roughly 200 milliseconds, and the entire system was back up online. Let's kill another satellite. Let's go here. That's only 4 installed. Let's get a good one here. Well, we'll take it anyway. So if I go to this satellite, I'm going to kill it too. It's gone. And let's see what happens. You'll notice that it's reconfiguring the inner satellite links. It's making use of different ships. And there we go. It's making use of different ships. It's now, you can see on the right-hand side, it's now an orphaned satellite. These are the things that we've only been able to talk about. Nobody really knew that we could actually do this. By imposing a strategic dilemma on our adversaries, one is not enough. What we need is a fire hose of strategic dilemmas that allows us to continue our order of battle and have our adversaries stutter step and say, why aren't they doing what we said or what we believe that they were going to do? We can go on and on and on. Here's a cool thing. I'm paying attention to time. So how then does this really work? So any DoD organization could have its own instance. Let's just say that ABMS and Convergence and Overmatch all had their own instances. But so does NASA, and so do some of our commercial satellite operators. What is remarkable about this is that we use open source APIs to connect everything that you want to connect from an asset perspective, but also allows us to federate different instances of space-time across different users. That means I can connect NATO to a Five Eyes instance, to an ABMS or all of the JADC2 instances, to NASA, to a commercial space network, and use all of them at the same time. Open source APIs, what does that mean to you? You don't have to spend, as a department, $1 billion, or somebody will tell you that they need $1 billion to be able to integrate to this. No, you can go to GitHub right now and download these APIs and connect whatever it is that you want to connect. Now, one of the things that this introduces is a discussion about governance. So if I'm working ABMS or I'm working Overmatch, but somebody else has some assets that I would like to use, there needs to be some sort of governance that allows us to go forward and do that. That's a better discussion than the discussion that says, can we actually connect everything to everything else? I'd rather have the governance discussion all day long than actually wondering whether or not we can actually connect things to each other. Here's the thing. It's a TRL-9 platform. It's on a DIU OTA. It's got 3 million flight hours on it. It works today. So you have to be asking yourself, well, Chris, why isn't it in the system? For every reason that every panelist spoke about during the day up here. And I've been in the system for 20 years. I understand how it works, and it's even painful and tough for us. However, we have fantastic champions. Certainly, Doug, welcome. DIU has just been fantastic champions for us. Space Systems Command, fantastic champions for us. Folks out at Project Overmatch, fantastic champions for us. So what is actually necessary for us to be able to do this? Here you go. A facilities clearance so that I can get permission to authenticate this on a SIPR or JWICS account, because that's where everybody wants all of this stuff to sit. That's one thing. We're working through that right now. Access to the data that says, here are the characteristics of my satellites, here are the characteristics of all of my antenna on my ship, planes, etc. That's a big deal, right? But there's ways for us to get through this in a classified environment. And then access to satellites. We're putting up so many satellites in space right now that being able to include space-time as a native function of a common control plane for communications on all satellites going into space would make our lives wildly simpler. Wildly simpler. So these are the conversations that we're having with everyone. I have to say, we've never walked into a room or a meeting where somebody said, that sucked, Chris. Like, that was horrible. But we do run into this, well, I've got some RDT&E money this year. I think I've got some extra money that I can throw onto this. We have to get this into the PALM effort. Everything that you heard today happens to us every single day. The great news is that everybody's trying to break that down for us and get us into the system. I will mention this. Non-traditional businesses like ours have amazing talent and amazing dedication to the mission. I mean, my goodness, my chief systems architect invented HDMI. Yeah, we don't have dumb people running around. We've got great people who want to contribute to the mission. The idea being, let us, help us complete the mission. With a TRL-9 platform like this, if you just did quick math in your head, you could advance JADC2 efforts by 5 years and for half the cost in no time. This could work today. There are many other assets that could help make a reimagined command and control environment real. You may have seen, if you're paying attention, that we released a press release today with Anduril. So Illyria's space-time platform and Anduril's Lattice platform are coming together to create an end-to-end command and control capability for the department. These are the things that the department should want, and they say that they want. We hope that we're going to be able to get through all the barriers to make sure that we can give it all to them. I've got 26 seconds, 25, 24. I won't answer any questions because I'm going to be at the reception, but feel free to come up and chat when we're done. Thanks so much from Illyria, and I'll get off the stage so the chairman of the Joint Chiefs can come up. Thank you.